All right, so let's kind of do some more conversion practice. So given that I have 8 times the cosine of 2 pi over 3 plus I times the sine of 2 pi over 3. I want to convert that to rectangular, but literally just for practice, let's go ahead and make exponential first. So I have an 8e to the I, and then what's my theta? My theta is 2 pi over 3. So that was just for practice. Now let's go through and change this into rectangular. So do I know, are these benchmark angles? Yes, they are. So what is the cosine of 2 pi over 3? The cosine of 2 pi over 3 is -1/2. Plus I, what is the sine of 2 pi over 3? It is √3 over 2. So when I distribute that 8, half of 8 is 4, and it's negative. And then half of 8 is 4, so I have 4i √3. Okay, so I just did this just for practice, just to keep it going. So I have 6 times e raised to the I times pi over 9. So I'm given exponential. I'm trying to go to rectangular, which means I need to go polar first. So my radius is 6, and then I've got the cosine of pi over 9 plus I times the sine of pi over 9, which means, sorry, I'm looking for my calculator, that I've got polar. Well, now I need to go rectangular. Pi over 9 is not a benchmark angle. And so I am going to go ahead and distribute my 6. So I've got 6 times the cosine of pi over 9 plus 6i times the sine of pi over 9. And now making sure that you are in radians first, I am going to say 6 times the cosine of pi over 9. What did I just do? 6 times the cosine of pi over 9. Okay, and I get 5.63, so I'm going to do 5.64. So 5.64 plus I. So then I've got 6 times the sine of pi over 9. So 2.05. I 2.05. So you could also say 5.64 plus 2.05 I, which is more conventional. Okay, so let's try one more time. Actually, let's not. That's a lie. Let's multiply. Okay, so I have z is going to be 5 times the cosine of 2 pi over 9 plus I times the sine of 2 pi over 9. And then w is 15 times the cosine of, oops, sorry, piece of trash. All right, plus I times the sine of pi over 9. And I want to find two different things. I want to find z times w, and I want to find z over w. So it will be very, very, very helpful if you will convert this into exponential first. So in exponential, my z is 5e to the I 2 pi over 9. And in exponential, my w is 15e to the I pi over 9. So if I want to take z times w, my z is 5e to the I 2 pi over 9 times my w is 15e to the I pi over 9. And then this is what I was screaming about earlier in the previous video. I've got 5 times 15 is 75. Okay, but let's use red. All right, so I have e to the I 2 pi over 9 times e to the I 1 pi over 9. So if I'm multiplying and my bases match, I add my exponents. So I have e to the I 2 pi over 9 plus I pi over 9, which means I can factor out that I. So 2 pi's over 9 plus 1 pi over 9 is 3 pi's over 9. So I end up with 75e to the I pi over 3, because that reduces. Okay, so I now know what z times w is in exponential form. So z over w is going to be, what's my z? It is 5e to the I 2 pi over 9 over 15e. I should have written this bigger. Pi over 9. Okay, so what is 5 over 15? It's 1/3. So I have 1/3. And then if I've got the same base, I wrote that stupid. If I've got the same base, I just subtract my exponents. So I have e to the I, and then 2 pi's over 9 minus 1 pi over 9 is 1 pi over 9. So I want to write those. I now have those in exponential form. Now I want to put these back in polar form, because I started in polar world, so we might as well end in polar world. So z times w in polar means I'll have a radius of 75 times the cosine of my angle. And even though it's a benchmark angle, do not simplify it from there, or you'll end up back in rectangular. So pi over 3. So 75 times the quantity of cosine pi over 3 plus I sine pi over 3. And then z over w is going to be, what's your radius? It's 1/3 times the cosine of pi over 9 plus I times the sine of pi over 9. Okay, so let's do one more like that, and then we'll kind of clean it up a little bit. Actually, this video is probably going to go a little bit longer, just because I don't feel like making a third one. All right, so I've got a z equals 10 minus 10i. And I've got a w is root 3 plus I. So first thing I need to do is convert into polar, and then I can get to exponential. Okay, so for z, I've got positive 10, negative 10. So my radius will be 10 root 2. And if this is positive 10 and this is negative 10, then the sine of theta will be a negative 10 over 10 root 2, which will be a negative root 2 over 2. So my radius for this is going to have, what's my radius? A 10 root 2. And my theta is going to be 7 pi over 4. Okay, so I don't really have, this is what I was talking about earlier as well. I've got all the information that I need to go straight to exponential. Okay, so I don't have to write it in polar first, because it's going to be beneficial for me to just go ahead and put it in straight into exponential. So for w, I have a positive root 3 and a positive 1. Okay, so if I use if I use Pythagorean theorem, I'll find out that that's 2. Using Pythagorean theorem, I have a width of root 3 and a height of 1. Pythagorean theorem says that my hypotenuse is a 2. So what is the sine? Where does sine equal 1/2 in quadrant 1? That's going to be a pi over 6. So my r is 2 and my theta is pi over 6. So now I know that z times w is going to be, what is z? Z is going to be 10 root 2 times e to the I, 7 pi over 4, times w. What is w? W is going to be 2 e to the I, pi over 6. So when I multiply those together, I get 20 root 2 e to the I, and then 7 pi's over 4 plus a pi over 6 is going to be 21 pi's over 12, plus 2 pi's over 12 is 23 pi's. over 12. So what does that look like? Because we're supposed to convert back into polar. So polar is going to be 20 root 2 times the cosine of 23 pi over 12 plus I times the sine of 23 pi over 12. So what about z over w? So z over w, what is my z? Well, there's my z, I already found him. He's 10 root 2 e to the I 7 pi over 4 over, what's my w? My w is 2 e to the I pi over 6. So 10 root 2 over 2 is 5 root 2. And then I've got e to the I. 7 pi's over 4 is the same thing as 21 pi's over 12. Minus 2 pi's over 12 gives me 19 pi's over 12. So that's exponential form. And then polar form will be 5 root 2 times the cosine of 19 pi's over 12 plus I times the sine of 19 pi's over 12. Okay? So, a couple more. Let's do rectangular form. So, like I said, this one's going to go just a little bit longer just so that we can knock it out. So, I have... Hang on, let me make sure that's a good idea. Yeah, sure. Okay. I'm still going to do a third video. Anyway, all right, so I have 2 times the cosine of pi over 18 plus I times the sine of pi over 18. And I want to raise that entire thing to the third power. So looking back through, where did my notes go? Where is De Moivre's theorem? I've lost it. It's gone. Found it. All right. So, looking at De Moivre's theorem. De Moivre. Okay. If I raise z to a power, as long as I am in exponential, life is going to be really easy. Because I'm just going to raise the radius to that power and then take, because remember all you're doing is adding. If your base is matched, you just add up your exponents. So if I have however many thetas, okay, so I'm going to convert this into exponential first, do my work, and then I'm going to convert back. Okay, so in exponential, what I have is 2 e to the I pi over 18. Well, what I would like to do is raise that to the third power. So I've got 2 times 2 times 2. And then e to the I pi over 18, e to the I pi over 18, e to the I pi over 18, which means I really have 3 e to the I pi over 18s being multiplied together. So I end up with 8 e to the I pi over 18 times 3. So that's going to reduce to pi over 6. So I have 8 e to the I pi over 6. And when I convert that back into either rectangular and or exponential, so I'm in exponential, I need to get to rectangular. So I need to get to polar first. So polar says I will have 8 times the cosine of pi over 6 plus I times the sine of pi over 6. Okay, so that's polar. That's where you would stop. But I want to go into rectangular. So I need to know, are these benchmark angles? And they are. So what's the cosine of pi over 6? It is root 3 over 2. Plus what's the sine of pi over 6? It is 1/2. So in rectangular form, I've got 4 root 3 plus 4i. Okay, try it again. So I have root 3 times the cosine of 5 pi over 48 plus I times the sine of 5 pi over 48. And I'm going to take that thing to the 8th power. So again, it's going to be a whole lot easier if we go exponential first. So what's my radius? It's root 3. And then I've got e raised to the I, 5 pi over 48, but I'm going to raise that whole thing to the 8th power. So side note, root 3 can be rewritten as 3 to the 1/2 to the 8th power. So that's actually 3 to the 4th, and 3 to the 4th is 81. So that gives me 81 e to the I, and then my 5 pi over 48 is going to reduce with that 8 to be 5 pi over 6. Okay, so I've got 81 e to the I, 5 pi over 6. So I need to convert back into rectangular, so go polar first. So polar is 81 cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. So that's polar. Now go to rectangular, so I know these ratios. So 81, the cosine of 5 pi over 6 is going to be negative root 3 over 2 plus I times the sine of 5 pi over 6 is 1/2. So that gives me 81/2 times root 3, and it's negative, plus half of 81 is 81/2 I. Okay, so we're going to do a couple more of those, and then we're going to do some roots.